morning, everybody. Okay, let's continue our discussion. We have one more model to talk about queue before we can generalize it to multiple queues in a network. And that queue is what is referred to as an MG1. So let's understand this. Again, you should have taken a little bit of this in 5.3, but just in case you didn't, let me just show you highlights of this. The M stands for what? Boson. Arrivals. Boson arrivals. G stands for general service time. General service time means the question will give you Fs of t, which is the PDF of what? Service time. Remember, again, recall, if S is exponential, if X is exponential, then Fs of t equal to e to the minus mut. This is what we have been using so far. Clear? This is what we have been using. Exponential, that the service time is exponential. But the service time does not need to be exponential. Does not need to be exponential. As we will see in just a second, if the packets are of fixed length, if all the packets are of fixed, this is, we will see this situation in ATM. ATM stands for the asynchronous. You will see that all the packets, we call them cells, are of fixed length. If all the cells are of fixed length, then the service time will be the same for all of them. The service time will be the same for all of them. So we'll call it deterministic in just a second. A one here is a what? A single server case. We are only going to be discussing a single server. For multiple server, it becomes a little bit what? More advanced. And the EE, again, as I told you last time, EE 549. Which is this class is dedicated for queuing. Ours is not. I'm just giving you highlights. Okay, so what we are going to be doing. How is this different? How is this queue different than what is this type different from the initial service time case? And the answer to that, here, we need to worry about what is known as the residual time. What does that mean? What does that mean? This is what it means. Let's assume this is the time axis. And let's assume these are what? Service time. So, for example, this one here, this is S1, this is what? S2, S3, and, S3, and so on, so on. Okay, so during this time, serving what? Packet 1. Clear? This one, he is serving what? Packet 2. Now, he is start 3 at this point. A packet arrived into the router. This is an arriving packet. An arriving packet. In the case of exponential, in the case, where is the residual time? Where is the residual time for packet 3 that is already in service? The residual time is this residual time. Are you following that? Remember, packet 3 started service at what point? At this point here. The packet arrived, the new packet arrived. This amount of time has what? Elapsed. Clear? This one here is what is referred to as what? The residual time. In the case of exponential, because exponential has the properties of memoryless, the distribution is what? It's also what? It's also exponential. Are you following? Because exponential, you don't need to worry about when did you start service. The remaining service will also be what? Exponential with the same parameter. It was general. If the service time was general, this is not the case. This is not the case. For example, if it was deterministic, let's assume that service time was deterministic. If you know when did you start service, Yes, and you arrived at this point. If the packet arrived, figure out how long is this. You can figure out how long is this if the service time is deterministic. Are you following? If you know when you start, you know how much is left. Clear? So we need to worry about what to worry about. What is E of what? E of R stands for what? The expected residual time. The expected residual time. How much is this? On the average, how much is this? Now, the expected residual time can be, expected residual time is the E or given that the server is what? Busy times the probability that the server is what? Is busy. Busy with what? When I say busy, what does it mean? Busy packet. Clear? Okay. Plus the expected value of R given the server is what? Idle times the probability that the server is idle. Clear? Called this equation called the total expectation. Total expectation. Answer me the following. What is this? Are you following me so far or not? What is the expected value of R given that the server is idle? Is the server is idle, the arriving packet will start what? Start service immediately. There is no. Did you get this or not? Did you get this or not? If the server is idle, then the incoming service right away. Clear? So this one is equal to what? Equal to 0. Now, the E of R given the server busy, the derivation of this one takes about an hour. So I will be posting it on what? I will just post the derivation of this one on the post, on the web. Right now, I'm just going to give you so that you understand what I'm talking about. It's E of S square to E of S. Again, proof will be what? Posted. You can read it yourself. It's a straightforward proof, but it's a little bit long. E of S square over 2 E of S. Remember, this is not the expected residual time. The residual time given what? That the server is busy. Keep that in mind. Where? E of S square. Anybody? What do we call this? That's the mean square time. The mean square time. Mean square time means what? You take the S, you square it, and then you take the what? You square it, and then you take the average. What is this as an equation? As an equation, what is it? 0 from where to where? 0 to infinity of what? T squared Fs of t dt. Clear? Or S doesn't matter. Clear? Okay. Now, again, recall, by the way, recall square E of S square is the what? Is the variance of S. No. Plus E square of S. The V of the mean square is equal to what? The variance plus, what is this in words? What is this? Don't confuse this with this. This is the mean square. This is what? Square of the mean. Or the variance of S equal to what? The mean square minus square of the mean. Is this positive, by the way? Is this positive? It's positive. Why you hesitated? Why you hesitated? I have a random variable. Squaring it, when you square it, it becomes what? Positive. And you are taking what? Average of a positive random variable is also what? Positive. So this one is positive, and this one is positive, but this one. Why? Because the variance cannot be what? Negative. So this one. Clear? Okay. Now, can we calculate this? E of S square. The question will give the PDF of the service time. Clear? So you use this equation to calculate what? E of S square. Like S, of course, is the what? E of S is what? Is the mean of what says? The service time. Clear? Clear so far? I'll go in just a second. Are you following me? Okay, good. Now, E, this is what we are interested in. E of R, help me. E, the server is busy, which is what? E of S square over what? 2S times. The probability that the server is busy. First of all, what did we call it? The probability that this is a single server case. The probability that the server is rho. Rho is the server utilization. You follow me? What was the server utilization? Exponential service time. Lambda over mu. Yes? In the case of general, what is it? Times what? E of S. Lambda is the average arrival rate. E of average service rate. In the case of exponential, what is E of S? 1 over mu. So over mu, which is the server utilization. But in general, it's what? Lambda times what? E of S. Did you get this? No response. Did you get this? Okay, so I cancel this with this, and I end up with what? E of S square over what? Over. This is what? What is this in words? What is this in words? This is the average residual time. Residual time means what? Means an arriving packet when he sees what? He is going to what? This is how long he is going to wait on the average until the packet that is in service exits the system. Clear? Exit the system. Are you following me on that? Yes or no? Okay. Let's see if you can help me now. Now let's go back to what? This is the queue. We will look at a single priority. Shortly, in a minute, we will look at what? Multiple priority. So we have a single server or what? Incoming. Now, this is a packet. A packet arrived at what? Some T, some value. Clear? On the average, have to wait. On the average, how much does he have to wait? W represent. E of W is the average waiting time. Is the average wait clear? Give it to me. What is? Now, first of all, he has to wait what? E of R, arrival time. Agree? Plus all the packets. Remember, this is what is the queuing discipline. The queuing discipline is still what? First come, serve. We'll talk about priority queuing in a minute. This is still first come, first serve. What does he have to wait? To wait for all the packets that are what? Waiting ahead of it to be what? Served. Are you following me or not? What do I write? E of what? NW. What is E of NW? E of NW is the average number of packets wait you times what? E of S, which is what? Service time. The average service time. Remember, this is all the packets are of the same priority. No priority served with the same what? With the same distribution for the service time. Clear? Are you losing me here or not? Okay. Do I add the service time of the arriving packet? Why? Because I'm only interested in the what? In the waiting time. Clear? What's in words? This is the average number of packets waiting ahead of who? Ahead of this arriving packet. Ahead of this arriving packet, there's the average number of packets waiting. I have E of W equal to what? E of R plus. What is E of NW? What is E of NW? Using little steer. Using little steer. It's lambda times what? E W. Clear? Times what? E of S. Are you following me or not? Okay. Can I, what is lambda ES? Rho is equal to what? Lambda E of S. So I bring this one to this side, and I end up with what? Of W is equal to what? E of R divided 1 minus rho. Yes? This is equation 1. And remember, for a single server, case, rho has to be what? Less than 1. You see why? If rho is equal to 1, what happens? So the E of W will go to what? Clear? Okay. Once you find E of W, by the way, do we know E of R? It's the question. The question will give you the what? The service time, as I was showing just said. Clear? Okay. Once you find E of W, then what? What is E of T? E of T is what? E W plus what? E of S. You have this, you got this. You can get this. Once you find this, can you find this? E of N. What is E of N? E of N is the average number of packets in the system, both waiting and being what? It's lambda times what? E of T. Are you following me or not? I had it what? Just to plug values and you can see, you can get the difference. That was easy. Clear? Okay. Let's take a numerical example or two so that you understand it before we get to the example. Compare the average waiting time and total average total time for MM1 and MD1. We are going to use this model shortly in our discussion of ATM, so I need you to understand what is the deterministic. The service time, constant. And it's equal to what? 1 over U. I need you to understand, what is the average time here? Average. So is what? 1 over mu. Same average service time. Do they have the same average service time? If the service time is constant, then the average is the same as what? That value. This is what? 1 over mu. The reason that I chose this 1 over mu because I want to compare what? Apples with what? Apples. The average, the service time is what? It's the same. Clear so far? Okay. Let's see if you can help me. M1. What was E of T? I don't have, but I'll see. 1 over what? Mu minus what? Remember this equation? Clear? 1 over mu minus lambda. And what is E of W? E of W is equal to what? E of T minus what? E of S, which is equal to what? 1 of minus lambda minus what? 1 over mu. Clear? You can write it as this. Mu times what? Mu minus lambda. This one is what? Mu minus mu plus lambda, so it's what? Lambda. Or you can write it as what? Rho over what? Mu minus, so this one, equation 1, this is the first one, and this is the second, for the MM1. Clear? Okay, good. For the MD1, what is the equation for the MD1? MD1 is what? E of W, which is the average waiting time, is what? Is E of R divided by what? 1 minus rho. Clear? Okay. Now, what is E of R? E of R is equal to what? Lambda E of S squared over what? 2. Clear so far? Okay. What is E of S squared? This E of S squared. Now remember, one more time, what are we looking at? We are looking at which is what? Constant. When I say constant, S is equal to what? 1 over what? Mu. Clear? Constant. It is not a one variable. Did you understand what I just said? Oh, no. Deterministic means what? It is constant. What? The average value of S is the same as the value of what? S. You are losing me? What does deterministic mean? When I say the service time is deterministic, I know it. I know it. It's not a random variable. Clear? So the average is the same as what? What is the expected value of a constant? Is the what? Constant itself. E of what? S. S is a constant. What is it? S. And that value is what? What is E of S square? 1 over mu square. Did you get this or not? Over what? Mu square. Times what? Lambda 2. Oh, sorry, I'm sorry, that's ER. I'm sorry. Sorry, that's E. Very good. That's E. Clear? Which means what is E? Oh, what is E of W? E of W is equal to what? R, which is what? Oh, by the way, what is lambda over mu? What is lambda over mu? So it's what? It's rho by 2 mu. Clear? Rho by 2 mu divided by what? 1 minus what? Clear? Equal to what? What is rho? Lambda over what? Mu. Yes? Which means what? Mu minus lambda over mu. The mu cancel with this. So I end up with what? Over what? Mu minus lambda. This is E of W in a what? M D1. What is this? This is E of W M comment. Comment for me. Look at this one. We say what? We say E of in an MD1 is what? 1/2 E of W in a what? M. The average waiting time is what? Is 1/2. What does that tell us, by the way? The network prefers something which is what? Deterministic rather than something which is what? Random. It would like to have some kind of a what? Predictability. If the network, listen to me, for example, it's exactly how much traffic is coming in, what is the what length of the packets, and so on and so forth, all of these information ahead of time. Will it be better or worse? It will be better because then it can what? It can allocate the resources properly. It knows what is coming. Problem with the network, with the traffic is that what? It is what? Random. And this is just a what? Case. Clear? The more fluctuation, the more random the traffic is, the more what unpredictable network will behave or will see, resulting in what? Increasing of average waiting time. Clear? Now, and then what is E of T? E of T for MD1 is what? Is E of W plus what? E of S. 1 over mu as fixed. Clear? That was a simple example. What it means E of T. By the way, is this the same as for MM1? Why? Because what? Comparing the two systems with the same average service time. So this one will also be what? Less than E of T for an MM1. Clear? Clear? Okay, good. Let's take another example. This model, the MD1, again, we will be interested in it when we get to the ATM. Why? All the packets are of the same what? Length. By the way, what do I mean by saying service time? Say the service time. What does it include? It includes the transmission time. Are you following? The transmission line time for the router to what? Transmit a packet. Once the packet is transmitted, the router is out of the service time. Clear? Okay, good. Now, example before we get to the priority stuff. Another example. I have a queue. Again, the incoming process are what? Goes on. Yes? But the difference in the previous one is the following. Is that here, the arriving packet will be served by either of two servers. So I S1 and what? S2. Yes? An arriving packet probability, let's say, just an example, let's say 1/4, it will come whatever, and a probability of what? 3/4, it will come to this server. Clear? Now, let me explain to you one more time here. This is not the same as what? A two-server case. In other words, this is not the same as what? What? MM2. In an MM2, when our arriving packet sees what? That is what? Idle, it will what? Join. In here, what? The arriving packets with a 1/4 will be directed to this server, and with a probability of 3/4 will be directed to this server. This server is exponential, which means the service time with parameter mu equal to what? 2. Clear? This exponential with parameter mu equal to what? 3. Which one is faster? Which server is faster? S2 is faster. Are you following or not? S2 is faster. Well, what? That will also explain why is this one with a probability of what? It will go to what? It will go to server 2. Clear? Clear? Okay. Now, answer. An arriving packet, pick at random, an arriving packet is the service time. Is it exponential? Did you answer my question? Not sure, did you get my question? An arriving packet, first of all, is this exponential? That's exponential. That's exponential. Clear? An arriving packet, a packet or arbitrary packet. Pick a packet arbitrary. What is the service time for that packet? Is it exponential? There is a possibility that this one is the server with a probability of what? 1/4 or what? This of what? 3/4. Is it exponential? And the answer to that is what? Let's see if you can help me. Okay, we need to find, what did I tell you a moment ago? The PDF of the service time. I told you this will be what? Given? Clear? Is it given in the question here? No, it's not given in the question. But can we calculate it? Let's see if we can. We need to find. Are you losing me or following me? I get depressed if you lose me.
Time is 0.
F S of T, which is the what? Which is the PDF of the service time. Let's see if you can help me. What is Fs of T? Fs of T is what? Of T given server 1 times the probability that is server 1 plus what? Of T given that is server 2 times the probability of what? 2. This is called what? This is called the total in terms of what is this? In words, what is it? Not what is it equal to. What do we call it? Fs of T given server 1. That's the conditional PDF. That's the conditional PDF blinded by the probability that is server 1. Clear? Okay, answer me the following question. Exponential. This one. Is this one exponential? Yes, it is. Is this one exponential? Is this one exponential? No, that's not exponential. Did you get my point or not? That is not clear. I will ask you what is it called in just a second. Let me set it up. What is it equal to? Give it to me. Give it to me. F of S T, that it is what? Server 1. Server 1 is serving the packet. Yes? What is it? 1 over 2 times what? E to the minus. E. What is the 2? What is the 2? No, not 1 over 2. I'm sorry. 2e to the minus 2t, yes, times what? 1/4. You lost. Are you following me? Okay. Plus what? 3 E2T times what? 3/4. Oh, 3T. Jeez. 3T. Which is what? E to the minus 2T plus what? 9/4 E to 3T. This is what? Fs of T. Is this exponential? Exponential. That is not the exponential distribution. Clear? Let's see if you remember from 503. Did you take something like this in 503? Yes? We call it what? The exponential. This is again E. Clear? Clear? Okay. What is E of S? Still waiting. What is E of S? Do we know the E of S of this guy? What is it? What is the E of S of this guy? This one here. It times what? 1/4. Yes or no? Oh, in other words, let's write it. It's E of S given what? Server 1 plus what? E of S server 2 times what? Server 2. E of S given it was server 1. It's 1/2 times, yes, plus what? E of S given server 2 times what? 3/4, which is what? 8 plus what? This E of S. Clear? What else do I need to find? Remember, what do I have? I have E of W equal to what? I have E of W equal to what? E of R, 1 minus rho. Yes? Okay, I need to find, but E of R is equal to what? Lambda E of what? S square over what? E of S square. Yes? What is E of S square? E, again, is what? E of S square, given what? Times the probability. That is server 1 plus what? E of S square. Server what? 2 times the probability of what? Server 2. What is it? Remember exponential. Yes? What is the mean square of the exponential? For the exponential, the mean is what? 1/mu. Yes? Do you remember? Say that again. Mu square, which means what? What is E of S square? What? 1/mu square plus what? Mu square. Remember, is the variance plus what? Mean. Yes? Which is what? Agree? So what is it? Give it to me. 2 over what? There. Because the mu is what? Is 2. Yes? Times what? Yes? And plus what? 2 over what? This is 2 over mu square. One more time. Did you answer what it is? Okay, so it's 2 over what? Mu square, 1/4 plus what? 2 over what? Mu square times 3/4. Which is what? It's 2 over 4 is what? Plus what? Help me. 2 over what? 12. Did I mess up? Okay, so it's what? 1 plus what? 1/6. Or 20. Clear? Okay. Which means what? E of R. What? E of S square over what? This is this equation I'm using. So lambda, this one. Lambda E of S square over what? Over 2. This will be given in the problem. In problem. And this thing here. Clear? How you find what? E of R, and then what? E of W equal to what? E of R divided by what? Or rho. Where rho is what? What is rho? It's lambda times E of S. Where E of S is what? Can you zoom back, please, Elizabeth? This E of S is this one. At E of. Clear? Clear? And again, once you find all the rest using what? Using Little's theorem. You can find E of T, you can find E of N, you can find, and so on and so forth. Clear? Clear? Okay, good. Now, let's go on and get another types of models. Can you zoom in, please? More. Can you zoom more a little bit? Thank you. Okay, and QoS. Now this, I cannot assume that you have taken it in 503. Did you? For those of you who took the class with Professor Sonis, did you? Again, as I told you, I don't. Let's see if you can follow me with the same thing that we just did for other queuing models. Let's see if you can follow me. Now, what does this mean? Listen to what does this mean. By the way, this part of quality of service means what? Means the network is not going to treat all the packets. This will treat packets depending on their what? Priority. Their priority. In other words, it's no first come, first serve. It is now what? The packets with higher priority will be what? Packets of lower priority will be what? Will be delayed after the first priority here. We are going to take only the case in which we have only what? Two priorities. Extending that to multiple priorities is straightforward. Clear? Once you understand two priorities scheme, it's multiple priorities scheme. Clear so far? Clear so far? Now, with a priority, I have first of all what is known as what? What is non-preemptive means? Non-preemptive means what? If a packet of a priority high to the system and found the server serving a packet of lower priority, it will not what? Preempt it. In other words, the server will continue serving the lower priority packet, and when it is done, it will the higher priority packets, even if there were what? Lower packets waiting ahead of what? The higher priority packet that just came. Follow me, or you lost me in the middle of the sentence. Did you follow me? A packet of it came. The server was already serving a packet of what? Priority. The service will not be preempted. First of all, do you understand what preempted means? It will not, the server will finish service the what? The lower priority packets. But after its served packet, even though there might be what? Lower priority packets waiting ahead of what? Ahead of the packet of higher priority that just arrived, the server will serve who? The higher priority. Did you get this or not? Okay. The is called preemptive. Preemptive. And the preemptive can be divided into two parts. Restart or resume. What does, first of all, do you answer what preemptive means? A packet with higher name found the server to be what? Busy serving what? Serving a lower packet. Restart means what? the server will stop servicing the lower priority packet. It goes what? And serve the higher priority packet. And then what does it do? The service of what? The lower priority packet. But keep in mind, no more what? Higher priority packet in the queue. Clear? It will restart, which means where it served the packet, the lower priority packet, partially, does not mean anything. You are going to what? Did you get this or not? The other one is resume. Resume means what? After you get preempted, you continue service the what? The remaining of the priority packet. Did you get my point or not? Yes or no? Clear? Of course, I'm not going to show you all of them. I'm only going to show you this one, and I will assemble. And the TAs, Angelos and Nacho will give you problems, not this week, next week. I mean, we'll explain this one to you a little bit more. Clear? No response. Clear? Okay. Let's see if you can help me here. So, preemptive. Queuing. So case, assume we have two priorities. 1, 2. So priority 1, priority 2. Priority 1 is higher than what? Priority 2, which means what? This is high priority, low priority. Clear? High priority, low priority. Clear? Are you following me? Okay, good. So, this is the what? Low. Packets. Can you tell me what is lambda 1? Average arrival rate of packets of what priority? Clear? This, what? Lambda 2. By the way, the arrivals are what? Poisson. Clear? What is lambda 2? Is the average arrival rate, lower priority. Clear? This now, are you following me or not? The server. Notice, by the way, the server, this S, depends on what? Depends on whether it's a what or whether it's a what? Lower priority. Are you following me or not? Two different things here. Clear? Okay. When I use S1, what does that mean? When I use S1, what does it mean? This is the service for what packet? S2 is what? Service of what? Lower priority packets. Clear? Clear? Lambda, sorry, row. What is row 1? What is row 1? This is the what? The server utilization. Serving which packets? Priority 1. Clear? Okay. What is row 2? Server. Serving what? Priority? Priorities. Row 1. What is row 1? Lambda 1 times what? E of S1. Did you get this or not? Yes? Okay. Notice, by the way, the question will tell you what? The service distribution. The question will get you the of packets of priority 1, service distribution of what? Packets of priority 2. Service distribution. They could be the same service distribution. Clear? But it does not have to be that way. Clear? Okay. Row 2. What is row? Row is the what? Total server. And of course, this one is what? Is row 1 plus what? Row 2. Clear? row 1, row 2. The server is either serving packets what? Packets of high, lower priority. Server utilization is the combination. Okay. And lambda, which is the what? Total average. Arrival rate. What? Is lambda 1 plus what? Lambda 2. Clear? Lambda 1 plus lambda 2. Clear? Yes? Let's see if you can set it up for me. Of W1, what is E of W1? What is 1? The average waiting time, average waiting time of packets. What? 1. Now answer me the following question. When waiting time, remember, this is not the total time. This is just in time. Clear? On the average, how much is the waiting time for packet priority? Now answer me the following question first of all. A packet of higher priority, does it depend on how many packets in the queue? Does not depend on it. Why? Why? Because the server is going to serve it first. What does this one depend on? It depends on what? How many packets of high priority in the queue? Yes? Of high priority. Yes? Plus what? The residual time of the what? Of the server. Yes? Did you follow me? By the way, that's what type of a priority the server was serving while high priority arrives. Whether it's what? Whether it's priority 1 or whether it's what? Priority 2. This is a what? Non-preemptive. Yes or no? And so what do I'm still waiting. How do I set it up? How do I set it up? E of what? R. What is this? That's the expected time. Yes? Plus what? Remember, no, give it to me in terms of packets before you change it to land. Remember, do I care about how many here? Care about me here. How many here on the average? E of what? N, W, 1, and M will take on the average E, S1. Did you get this? Yes. Yes or no? And what is this? This is E of R plus. What is E of NW1? What is E of N using Little theorem? Lambda? Lambda? Yes or no? Times what? E, W, 1. Yes or no? Times what? Did you lose me? What is E of NW1? What is E of NW1 in worse? Is the averages of priority what? 1 that are ahead of who? That arriving packet. Clear? Yes? E of NW1 and E of N lambda 1 times what? E of W1. Clear? Okay. What is lambda 1 E? Row 1. Clear? Which means what? E W1 is equal to what? E of R divided by what? 1 minus row 1. Clear? Okay. That was straightforward. You agree? See if you can help me with the next one. What is E2? What is E of W2? E of W2 is what? How long with a packet of a priority 2 will be what? Waiting. Verbally. What is it? Verbally. How long does he need on the average? A packet of a priority what? 2. Now, first of all, he needs to wait what? The residual time. Are you following me or not? For what? For the packet that is already in what? In service. So this is E of R. Same thing. E of R. The question matter whether the packet in service is a priority 1 or a priority 2? No, it doesn't. Why? Because it's non-clear. You need to calculate the average. Are you following me or not? Okay. Then what does he have to wait? What does he have to wait? He has to wait for all the packets that are in the queue of what? Higher priority to be what? Served. So here E of N W1 times what? ES1. Yes or no? Are you following? Okay. Are we done or not yet? Wait for. He has to wait for all the packets of what? That are what? Ahead of it. Ahead of it. Who's it? Who's it? And arrive for priority what? 2. Clear? Clear? So what is that? W2 times what? Clear? Clear so far? Are we done or not yet? Not yet. What else does he have to wait? He has to wait for what? All the packets of a priority 1 that arrives while he is waiting in what? In the lower priority queue. Did you get my point? See if you can. E of, let's use M, times E of S1. What is EM? Where M is what? The number of priority packets arriving while our low packet waiting its turn to be what? Clear? I'm not sure. Let's concentrate. An arriving packet of what? Lower priority. What? Let's see, what does he have to wait? The packet that is already in service needs to what? Finish service. Clear? That's the residual time. Yes? Regardless of what is of what? Higher priority or what? Lower priority. Do we agree on this term? Do you agree on what is this term? All the packets that have been for which priority? Priority 1 needs to be what? Served. E of NW1 times what? E of S1. Agree? Okay. What is all the packets of what? Lower priority that are ahead of our packet. What our packet? Our packet is this one, the one that just arrived, of a lower priority. All the packets needs to be served because it's what? As within the same priority, by the way, within the is it first come first serve? Within the same priority, is it first come first serve? Clear? Clear? While our packet is waiting, that higher priority packets will be arriving. All of them will be served before what? Before our packet. That's this one. E of M times what? E of S1. Why am I multiplying by E of S1? Of these higher priority packets, on the average, will take what? E of S1 to be served. Clear? Let's see if you can set it up for me. What? Yes?
We're serving the priority one in the first case, and there's still arriving on new packets.
All of them will be counted. The question is what? I don't need to repeat the question. There are no dense students. I keep forgetting. Concentrate. What you are telling me, can you, I don't know what you are telling me. I forgot the question. Repeat the question. Can you speak louder a little bit?
First, you're dealing with priority 1 case, right?
Which is all of them
Yeah.
already there before this one arrived. This term.
But while you're doing the packing of the queue, there's still new arriving.
Going to be here. That's this term.
Okay.
In other words, while this one is waiting, there are higher priority packets coming. It needs to be what? It needs to be served before. Clear? It will be clearer when I write the equation. Can you give me 1 minute? You have no choice. Okay, I will show it. What is E of W? Let's see if you can help me. What is E of R? We will calculate plus. What is E of NW equal to? Can you zoom back, please, a little bit? Thank you. What is U equal to? E of NW. E of NW is the what? Average number of packets of what? Higher priority waiting to be served. You are struggling here. It's what? Land E of what? W1 times what? E of what? S. Clear? Okay. Plus. What is this? Lambda 2 E W2 times what? E of S2. Clear? Let's see if you can tell me what is this. What is EM? What is EM? Now let me repeat it one more time. Let me repeat what more time. E of M. M is the average number of packets of higher priority arriving while the lower priority packet is waiting. Waiting where? Waiting in the lower priority queue. Clear? It's lambda 1 E of W2 times E of S1. Did you understand why is this one E of W2? Priority packets are arriving at what rate? At a rate of what? Lambda 1. You need to what? You need to take that into account while the lower priority packet is what? On the average, how much is the lower priority packet will be waiting? E of W2. Clear? Clear? What is this? E of W2. E of R. Plus. What is lambda 1 E of S1? Times what? E of W1. Plus. What is lambda 2? 2. It's rho 2. Times what? E of W2. Plus. What is lambda 1 E of S1? Times what? E of W2. Which means what? Of W2 is equal to what? E of R rho 1. E of W1 divided by what? 1 minus rho 1 minus rho 2. Did you understand where it came from? Bring this one and this one on this side. So it's what? 1 minus rho 1 minus rho 2. Or E of W is equal to E of R plus rho 1. Now what is E of W1 is what? E of R over what? 1 minus rho 1 and divided by what? 1 minus rho 1 minus what? Rho 2. Which means what? E of W2, what? E of R minus rho 1 E of R. So this one will cancel and you end up with what? E of R divided by what? Minus rho 1 minus rho 2 times what? 1 minus rho. Clear? The gentleman here. Clear? Or is still not confused? Cannot hear you.
I'll just talk you to after.
Oh, after class, that's fine. Okay. Now, stability to ensure with E. Oh, sorry. Ensure means insurance. To ensure stability, what do I need to make sure? First of all, row 1 is what? Less than 1. Yes? Why? Because if row equal to 1, what is EW of 1 equal to? Equal to infinity. What else do I need to make sure? What else do I need to make sure? I need to make sure that plus what? Row 2 also be what? Less than 1. Otherwise, for the what? Lower priority queue will go what? Will go to infinity. When we talk about QoS, we will call what? The lower priority is starving. Why is it starving? It's not getting any service. Why? Because the high priority, what? Keep coming, and the lower priority packets are being what? Stuck. That, by the way, that's one reason why we will the most important queuing discipline, which is what is known as what? Weighted fair queuing. We will weight the traffic different ways, and we will try to what? This in a fairly way, rather than in a what? In a harsh way. This is a harsh way. Clear? The way. If users with high priority packets are what? Abusing the system. Abusing this, sending higher priority packets, and so on and so forth. Yes? All the lower priority packets will what? Will suffer. Did you get my point or not? Yes or no? Oh, now what do I need to find? I'm not finished to find in this equation. Remember, by the way, once you find E of W1 and E, the rest will come what? Smoothly. For example, what is E of T1? What is E of T1? First is the average total time spent in the system, both waiting and of what type packets? Priority 1. What is it? It's E of W1 plus what? E of S1. Did you get? Yes or no? So once you find E of W1 and E of W2, all the rest mostly. Clear? What is the unknown here? I need to find. I need to find what is E of R. Okay? Yes? What is E of R? E of R is what? Is lambda E of S square over 2. Clear? Clear? No response. Okay, where what? Lambda 1 plus lambda 2. Now, what is E of S square? Still waiting. What is here? E of S square is what? E of S square given times what? The probability that it's a what? Priority 1, yes or no, plus what? E of what? Given what? Priority 2 times what? That it's a what? Priority 2. Clear? I'll see if you can help. E of S square, given that it's priority 1, is E. Do we agree? Given that it's a priority 1, what is the average what? What is the mean square? Mean square is what? E of S will be given in the problem. Did you understand that or not? Thank you. Did you get my point? The question will tell you what? The distribution of what? The service times for the higher priority and the what? Lower. Here? Okay. What is the probability of a priority what? Packets. It's a proportion. A probability is what? Is a ratio. Yes? Of what? Lambda 1 over what? Are you following me on that? It's lambda 1 over lambda. Lambda is the what? Is the total rate. Lambda 1 is the what? Is the average arrival rate of what? High priority packets. The rate probability. Clear? So what do I have? I have lambda 1. So ER equal to lambda Lambda 1 over what? No. Lambda over 2. This lambda 2 over 2 is this lambda over 2. Times what? E of S1 times what? Lambda 1 over lambda. Yes? Plus what? E of what? S times what? Agree? Which is what? E of R is equal to what? 1/2 lambda I E clear? Clear? What happened to this lambda? This lambda cancels with this lambda. Cancels lambda I E of S. Clear? Once you find E of R, then you can go what? And plug it in here and you find what? All of these things. E, for example, what is E of T2? What is E of T2? E of plus what? E of S2. What is E of T1? Is what? E of W1 plus of S1. All of them require E of R. So once you find E of R, then you go and plug it. Now, in the general case, we have K priority classes. What is E of WK? I want you to see this equation. How many priority classes did we have here? Priority classes did we have here? 2 priority classes. Suppose we do have K priority classes. K4 all the way to what? K. What is the expected value of the waiting time of the what? Is what? E of R divided by what? Let's see. 1 minus rho 1 minus rho 2 minus all rho K. Yes or no? Times what? Times what? 1 rho 1 minus rho 2 all the way to what? Rho minus 1. Close the bracket. Did you get it? Yes or no? Okay, so for example, what is the priority? What is E of W? What is E of W1? E of W1 is what? Is E of R is equal to what? 1. Yes? And so what it will be? E of R divided by minus rho 1. And this term 1, just 1. Because the E, K minus 1 here is what? Is 0. You follow me or not? Oh, what is E of W2 equal to what? E of R times what? 1 minus rho 1. 2 times what? 1 minus rho 1. What is E of W3? E of R times what? Minus rho 1 minus rho 2 minus rho 3 times what? Rho 1 minus rho 2. Did you get this or not? Yeah, but by the way, the condition is that the sum of these has to be less than 1. Sum of these has to be less than 1 for the Q to be clear. Clear? Okay.
plug.